We have question number 14 here, which is another vernier calipers question. So it reads, a vernier calipers has 1 millimeter marks on the main scale. It has 20 equal divisions in the vernier scale, which match with 16 main scale divisions. So for this vernier calipers, the least count is. Right.
Pretty straightforward question. I didn't even ask anything else, just to find the least count. So we'll use this formula 1 minus m upon n, where m is the number of main scale divisions and n is the number of vernier scale divisions.
Right.
So we know that a is equivalent to 1 millimeter, as is given in the question, that 1 millimeter marks.
Okay.
M is equivalent to 16.
16, which is the number of main scale divisions, and n is equal to 20, which is the number of vernier scale divisions.
Yep, true.
Right.
So therefore the formula becomes a into 1 minus 16 upon 20
right
is equivalent to 4 upon 20 millimeter.
Right.
Equal to 0.2 millimeter.
Okay.
This is the final answer, D.
Okay. So to summarize this, it's a very pretty straightforward question, and this is one formula which we need to remember right now. And this would be the least count, a into 1 minus m by n, and where a is equal to 1 millimeter, which is the number of the marks on the main scale, and m is the number of main scale divisions, and n is the number of vernier scale divisions.
Yep. One trick which could be implied if you don't remember that what is m and what is n, just remember this, that this value can never be negative. So therefore m has to be less than n. So therefore whichever is the smaller value, just put it in m, and whichever is the larger value, just put it on n.
Right, that's because obviously least count can't be negative.
Yeah.
Perfect. So this is question number 14, and the correct option is option D, 0.2 millimeter. So question 15 reads, the pitch of a screw gauge is 1 millimeter and there are 100 divisions on the circular scale. While measuring the diameter of a wire, the linear scale reads 1 millimeter and 47th division on the circular scale coincides with the reference line. The length of the wire is 5.6 centimeters. Find the curved surface area in centimeters square of the wire in appropriate number of significant figures. So since this is a screw gauge problem, I think we need to find out the least count. Am I right?
Yep, true, very true.
Right.
So the least count of a screw gauge will be equivalent to pitch upon number of divisions.
Okay, so the pitch is 1
millimeter.
Yeah, it's 1 millimeter, and the divisions are 100. Okay, so we got the least count as 0.01.
0.01 millimeter.
Right.
So now, according to the question, it is given that the linear scale reads 1 millimeter and 47th.
Yes.
So therefore, for this 47th, it is 47 into 0.01 millimeter.
True.
So therefore, the diameter of the wire will be 1 millimeter plus 0.01 into 47. Which is equivalent to 1.47 millimeter.
Okay, true. So now is it convenient to convert it into centimeter at this stage, or should we?
No, I generally prefer to convert everything in the end so that it is more convenient, because in this question you got only diameter and length. If there are 3 or 4 of them, then it becomes a little easier to convert it in the end.
True.
It is more convenient.
Okay, so now that we have the diameter, it must be pretty straightforward.
Pretty straightforward. Curved surface area
is equal to 2 pi RL.
2 pi RL.
Yes.
Where pi is 22 upon 7 into 2r
is diameter.
It as the diameter.
1.47 upon 10.
1 centimeter is equivalent to 10 millimeters.
Yes.
And the length is 5.6.
Okay.
So this thing comes out to be centimeter square.
Yes.
So this thing will cut from here 0.8, and finally we get 2.5872 upon 10.
Okay.
Is equivalent to 0.25872 centimeter square exactly.
Right. So now the question says in appropriate number of significant figures.
Yeah. And even if it is not given in the question in appropriate number of significant figures, you should obviously write it in significant figures.
Okay.
Because you might get it incorrect.
So what are the parameters of which the significant figures we need to consider?
See, the observations that we have is the diameter and the length.
Right.
So the length of the wire is given as 5.6 centimeter.
Yes.
And the diameter is given as 1.47.
Okay.
So this 1.47 has got 3 significant figures. And 5.6 has got 2 significant figures.
So the least number we need to consider.
Yeah, the least number. So this has got 2. So therefore our answer should also have 2 significant figures.
True.
So we'll round it off to 2 significant figures. That is 0.2 into something. So we'll progressively round it. 0.2587, 0.259 into 0.26 centimeters.
Perfect.
These steps we can do it manually, like in your head also. But just to show it over here. So the correct answer is 0.26. Okay. Just remember that the 0 is not counted as a significant figure as it is to the left of the digit.
Right. So this question we had to remember one formula: the least count is equal to pitch by the number of divisions in a screw gauge. Right. Yeah, so by that least count we immediately found out the diameter, and as soon as we found out the diameter, we knew the simple equation CSA, the curved surface area, is 2 pi RL. Of which we got this as the answer in appropriate number of significant terms. So question number 15. Yes, exactly.
This pretty easy question, and
true.
Just keep on following a little bit of what you know.
True.
And you'll get the correct
and
answer.
Yeah, this question is not that time consuming as well. It's just a couple of formulae you need to remember.
The only thing where you can take some time is in the calculation of the curved surface area.
Okay, yes, true.
So do that carefully. Don't do a mistake over there,
right,
and you'll be just fine.
Right. So that's question number 15 for you.